example it's a part. Thank you puro. We had to do calculation. And did you solve that question where water stream was going like this at an angle? I wonder who gets some answer. Right, wrong, you leave it to me. Who gets some answer? Yes, Gaurav, we'll start with you. I'm both of them. 1.12 kg. You did what? What to wait? Oh, 1.1 meter. Okay. May pull up you.
1.13 meter and minus 0.26 meter.
Don't you think the other one is nonsense? Other who has got an answer?
1.17 meter.
1.17 meter. धीरे धीरे बढ़ते जाएगा. 1.8 meter. Next. 1.13 meter. Okay, same here. And yes. 1.113. Take a seat. Okay. Anyone else? Come on, people. Yes. 1.1 meter. This same as this. Gaurav Dev answer. Coincidence? Pinda. Who else? Yeah, Arthur.
1.13.
1.13 meter. तो पूछो जो ले गोपाल coincidence ही है वो है नहीं गोपाल no है right it really depends on what you have. Never mind. So you have these four options. You have to choose. Eeny, meeny, mo. I don't know which one is that. So what was that equation? Equation तो लगाओ मैंने minus 0.2 is equal to delta x by root 3 minus delta x square by 10 into 3 by 4. અહીંયા ક્યાં ફાઈવ અહીંયા g આવે ને એટલે આમ હોય ને 1 by 2 g this.
सब नीचे 10
हाँ अच्छा velocity speed square agree. This is what we have, right? And for constant 10 cancel this 2 cancel here. Okay, so minus 0.2 is equal to delta x by root 3 and minus 2 delta x squared by 3. So this is a quadratic equation and there is no other option but to take discriminant, right? So पहला बोलो हम rearrange करना को 2/3 delta x squared minus delta x by root 3 minus 0.2 is equal to 0. Therefore delta x is equal to minus 1 plus 1 by root 3 plus or minus b squared minus 4b. Okay, बराबर ने? You can use calculator 1 by root 3 11 by 20 by 3 so 0.6 no 0.5 23 is 7 plus or minus here. तो खतरनाक है. हाँ तो 0.4 1.6 1.6.3 करो यार मत करो. How would I somebody check the expression first? If you get this, then well likely you would have got the right one. This would be square root of 1 by 3 and what can do that? 1.6 by 2. So 2.6 by 3 divided by 4 and 3 upon 3 into 0.57 minus 1000 plus 1000. Root of 2.6 by 3 can do that. Do it in a calculator. Divide 2.6 by 3. 0.8667 into square root. 0.93 divided by 4. So 3 into I mean add 0 1 5 1.5 3 1.5 by 4. So that is 4.5 by 4. So 1.1 okay, got it. Okay, right? So that's it. I hope this didn't create any kind of trouble for you. Quadratic equation solve करता तो तुमने आवडवी જોઈએ. આવડે છે મને ખબર છે આવડતું જોઈએ. Okay. Now let's solve more questions related to Torricelli's law. So let's think of a variation of the question. Okay, एक fluid वालों ने दे fluid. So let's say that there are two fluids. Okay, suppose this is oil and this is water. Okay, let's say we derive this by putting symbols, પછી value. Let's say this has density rho1 and this has density rho. Here is the hole. Above this hole, let's say the height is h1 and this height is h2. Have you understood what we have indicated so far? Water, oil. Oil floats above water, I'm telling you. Right? So let's say oil layer has height h2 and above the hole the water layer has height h1. Right? Then we are going to derive with how much speed this is going to come out. What will come out, oil or water? Water. So with how much speed water will come out? That's what we are going to find out. So, actually you could do it by Bernoulli's theorem, right? But we will keep it simple. We will do it for tiny hole, that is area of hole is much smaller than the area of the vessel. Okay. So what you can think is, if you have it like this V is there, fine. But suppose at this point, let's say A and then this point B, if you think of speed of fluid, I hope you understand this. Yes, no. Over here, fluid is coming out. This area is very small, but this area is large. Because the area is large, the speed is negligible. Clear equation of continuity, right? Similarly, this. So because they are very small, we are just going to assume, right? As speed is very small, we can consider the fluid at A and at B to be stationary. Stationary, that is not moving. Okay, we have neglected its speed. Fine. I hope the assumption is not a problem for you. We are having it because of this. The speed will be so small that we can almost neglect it. So we are assuming it's stationary. If you assume it's stationary, this part will just remain like that. It is in equilibrium. So what we can do is we can simply use the pressure variation formula. We can simply use the pressure variation formula and we can easily find out how much is the speed here. Right? Okay. So that's one shortcut way of doing it. Proper way is to do it by Bernoulli's theorem. Right? Proper way is to do it by the Bernoulli's theorem. Right? So this is how it works. Okay. Let's say that you consider, suppose there is only one fluid. I think I should explain a simpler case to you so that you can understand it easily. Right? I'm just doing it over here. Do you remember that when A is very small compared to capital A, we get V is equal to root 2 GH, yes or no?
Yes.
Now, what's a very quick way of deriving this? Without worrying too much about Bernoulli's theorem or anything. Let's say here is the hole, and this is a depth here. So do you realize that if I take a point here and a point here, let's say call this point 2, point 1. So then we should have P2 minus P1 is equal to rho GH. Yes or no? Yes or no? And Bernoulli's theorem is actually telling you that pressure difference, when you write it like this, it will become 1 by 2 rho V square. Where is the other velocity? We should write two velocities like this. But why are we not writing the other one? Simple reason, it is negligible. So immediately from this equation, have you V2 equal to, have you root of 2j? So this is a shortcut way of deriving. Is it perfect? No. We have jumped at so many places. If you understand, very good. If you don't, like I said, this is a shortcut where We are skipping over so many things. So we get this. So for a single liquid, this is how you do it. In short, the key thing, the main point that I want to make is that the pressure difference between this point and this point is what makes half rho V2 square. So if we use that idea here, what is the pressure difference between, let's say, this point C and B? So we have found pressure differences with height. We have found pressure differences with height earlier when there are multiple liquids. We did it in a case of U-cube. Do you remember there was a question where there was spirit and mercury and water. There we had to do it due to multiple liquids. So if I just want to find the pressure difference between C and B, it is going to be rho 1 G H1 for this part. Yes or no? Rho 1 G H1 for this part. Now the part above. Raise your hand if you understood this. Okay. Just like, you would do it in 2 steps. What would be 2 steps if you don't understand this? First you do PC minus P. Then you do PB minus, then you do PA minus PB and add equations. So when you add, PA will get cancelled and you will get PC minus PB. That's what this plus is. I hope you understand. Okay, તો આ સીધું લખાય. લખવાનું શીખવું એવું કઈ એવું નહીં રાખવાનું કે એવું ન લખાય. લખાય બધું લખાય. You should skip as many steps as you can and write. Okay. The only one condition that you need to follow is when you read it again, you should be able to understand what you have written. બીજું કઈ જોઈએ નહીં, right? You are not writing it for me. You are not writing it for anyone else. It's just for you. So PC minus PB is this. Like I said, as a difference આવે, that is what becomes half rho V square. So I should be writing it equal to half rho V square. Now which fluid is coming out? 1 or 2? 1. What is it? How we get formula? So whenever you have such a case, you can always do it like this. Understood? A shortcut use karo. What's that? The pressure difference here is equal to half rho V square. Enathi je V aave, that is always going to be speed of F. Understood? હવે આ question solve કરીએ. બરાબર. Let's say that height above this hole for water is suppose 50 centimeter and over here is, let's say, 1 meter. Okay, big vessel, 50 centimeter, 1 meter height. Okay, filled with water, filled with oil. And suppose, have you lucky little? Okay, it is. Okay. So suppose density of water is as usual 10 raised to 3 and density of oil, let's say, is 800 kg per meter cube. Now you have to find out with what speed will water flow out. With what speed will water flow out of coal. Okay. So how to solve this one? Use this idea. So first of all, I am going to write half rho for water into V square. Understood? Half rho V square. Because water is coming out. Equal. હવે શું લખવું જોઈએ? આ લખવાનું ને? What should I write for that? Let me write it. I want to write the pressure difference for this. What should I write? Rho, which rho? Water. Into G. How much is G? 10 into 0.1 plus then 800. Okay, then 10 into 10. Okay, into 1. And in all this, find out what will be the speed. Meanwhile, I will write a homework question for you. Okay. What's the answer? 5.09. Root 26? Yes. મને યાદ હતો root 26. I must say that. So here is the question that is for homework. You have to find speed of F flux. Okay? You have to find speed of F flux. Relevant heights are given. ખાલી diagram draw કરવાનો formula ના પછી ઘરે solve. Let's confirm that you got the right answer here. You can cancel 1000 with these things here. Okay, હવે તો આવ્યું v square by 2 is equal to 5 અને 8 30. હા બરાબર થઈ ગયું. v equal to root of 26 meter per second. Okay. Okay, before we go on to venturimeter, actually, I just recall yesterday I asked you to do a little experiment with a piece of paper. Did you do it?
Yes.
How many of you did? But how? ભૂલી ગયા બીજા બધા? Oh, ભૂલી જાઓ તમે લોકો. What did you see? What did you notice? When does it remain afloat? When does the paper just fly or float for a little bit more time?
From downward.
When you're blowing air from downwards. That observation is actually wrong. એનું reason મને ખબર છે તમે આમ angle ઉપર મારી ગયો. Okay. That was not to be done. I told you that you have to blow air above it and below it like this. આમ નહીં. આમ કરો તો બધા ખબર છે. Suppose you push it like this, then go down. Push it like this, it will go up. Up. You see the difference that I'm talking about?
Yes.
Everyone understood how to do it? Okay, so those who have done it, do try it again, like I'm saying, right? Don't try to push it up. You just try to blow air like this, see what happens, right? And those who forgot to do it, make sure you do it today, right? So here is the next topic, that is venturimeter. Now what's a venturimeter? It's a device that is used to measure speed of flow. It's a device that is used to measure speed of flow. That is how fast fluid is flowing. How fast could blood be flowing in your body? Of course, at different places the speed will be different. But let's say we take one particular artery or vein somewhere, right? Let's say here. Then how fast the blood is flowing over here? You get what I'm asking? So such questions can be answered by using a venturimeter. You just put a venturimeter, it will measure it, right? Okay. So what principle is it based on? It's based directly on Bernoulli, of course. Right? It is based directly on Bernoulli. Let's see. If you remember, we have solved questions like this earlier, yes? That is exactly what a venturimeter looks like. There is a broader section and there is a neck. And the neck, which is narrow. Now broad and narrow section. Okay, broad and narrow. Okay, and what we have along with it is that here there is a small tube. Okay, and this tube is connected to the narrow section like this. Okay, something of this kind. There is a U-tube. There is a U-tube, right? Okay. So, wherever you want to measure the flow speed, right? Speed of the flow. So, suppose here, like let's say there is a pipe. Okay. And it's not broken, of course. water is flowing, let's say. You want to measure when water comes over here, what is the speed? So what to do? Cut it open. Take that, fix it here. Understood? Right? So when you fix it here, what happens is that there is mercury in this tube. Okay, I'll have to draw a lot of it. When you don't attach anywhere, or when these two speeds are same, these two levels are also going to be same. I'll tell you what. Consider one point here, Both of these are at same height. Okay. And let's say that fluid is not flowing at all. Bandha hai, it flows not. Then speed over here 0, speed over here 0. So everything is in equilibrium. Then over here and over here the pressure has to be same. So these two remain at same. But now suppose that fluid is flowing. So here let's say speed is V1 and here let's say speed is V2. So in which case will the speed be more? Here, then in the broader section or in the narrow one? Narrow it is more. Yeah, the equation of continuity A1 V1. Right? So here speed is more. Fine. If the speed is more over here, what will be the pressure related? Which pressure will be more? Pressure at 1, pressure at 2? Pressure at 1, pressure at 2. Which pressure will be more? Pressure at 1 or pressure at 2? Pressure at 2. Pressure at 2 will be more. No, that's wrong. Pressure at 1 will be more. Bernoulli's equation is derived very good. Flip the pages of your notebook, you might find it somewhere. કાલે જ સમ કર્યો હતો આવા શેપ વાળો સમ કરાયો હતો ને આફ્ટર ડિરાઇવિંગ બર્નોલીસ થિયરમ એના પછી જ હશે there do we have such a similar question, not of vertical but of horizontal no નથી એને ઓલો n વાળો એવો કરાયો હતો right. So then I did ask you, I think, મને યાદ આવે છે સમજાવ્યું હતું તમને કે which point has more pressure. Here speed is more, so pressure is less because of Bernoulli's equation. If you write height is same, so P1 plus half rho V1 square equal to P2 plus half rho V2 square. Understood? Where is rho G at? Cancel. So both sides are equal. So if V1 is more, P1 has to be less. Similarly, if V2 is more, P2 has to be less. Okay, so depending on what's going on, here V1 is less, V2 is more. So because V2 is more, P2 has to be less than P2. Fine. So because pressure here is less, so do you realize that this mercury is now pushed down by less pressure, but over here this mercury is pushed down by more pressure. So will the arm stay same? Which arm will go lower? The one below broader or the one below narrower? The one below broader will go down. Make sense? Yes, and this one will go up. So when nothing is flowing, these are level. But when it starts to flow, this arm will go down. That one will go up. So what will be measured? Just like manometer. Manometer, yaad hai? Who hai manometer? You just have to measure the difference. Yaad hai? So that's it. Measuring the difference. Suppose we measure this difference. What does this difference tell you? The difference will tell you the difference of pressure, P1 and P2. Understood the concept? Measuring this difference of height will tell you pressure difference. P1 minus P2 can be written as rho mg h. Yes or no? Where h is height difference. Give manometer the same principle. I hope nobody has got confused. That's a manometer memo. Two arms. One stays higher, one stays lower. So the difference is P1 minus P2 is rho mg. Fine. बस तो P1 minus P2 मरी जाएगा ऊपर इक्वेशन जो from there can I find P1 minus P2? Yes or no? Sure? Absolutely clear? કે રીતે કરે આમ મૂકી દેવાનું બોલો આવી જાય got it. But I just like all of you to be careful. This density and this density, they are not same. What's this density? Density of fluid which is flowing. Suppose you are measuring the speed of blood in the vessels, then this would be density of blood. Suppose you are measuring with how much speed water is flowing in a pipe, then this would be density of water. On the other hand, this is density of liquid. Difference clear? Okay? Thank you, Raj. Benny? Okay, so you put P1 minus P2 equal to this and you solve this, right? Also, you know, when you do that, મને એમ થાય છે ડિરાઈવ કરાવું ન કરાવું કારણ કે ફોર્મ્યુલા બહુ મોટી છે યાદ એ ન રહી કરાવી ચલો વેધર યુ રિમેમ્બર ઇટ ઓર નોટ ઇઝ અપ ટુ યુ મને નથી યાદ રહેતી આઈ વિલ બી વેરી ઓનેસ્ટ વિથ ઓકે તો કે રીતે સમ સોલ્વ થાય કંઈ નહીં આ સ્ટેપ લખવાના પછી નંબર મૂકી દેવાનો કેલ્ક્યુલેટ કરવાનો આન્સર રાઈટ આ તો આવડે એવું જ છે આમાં તો કંઈ છે નહીં Okay. So suppose you want to derive it, then this is how it's going to be. So I am going to write P1 minus P2 from here. P1 minus P2 is equal to 1 by 2 rho V2 square minus V1 square. Yes or no?
Yes.
Now, what's the relation between A1 and V1 and V2? So suppose this area is capital A and this area is small a. Again, bigger area capital A, smaller area lower case. Clear? So, do you realize that we can write V is equal to A V1 for A? Yes or no? This is clear? Okay, here look. Okay? Okay, not okay? Fine?
Yes.
And what is P1 minus P2? હવે તો કરો we want to find out what is speed here અહીંયા કેટલી સ્પીડ થી ફ્લો થાય છે that's what we want to find out. So we will take common here. What's common? V1 square common. સમજાણું ને? And now V1 square is equal to, જો કેટલી મોટી ફોર્મ્યુલા છે, 2 rho m g h divided by હવે શું સ્ક્વેર. It's fairly big. That's why I never bothered about remembering it. Okay, this is the formula of speed of flow here. See, we always want to find V1. We never want to find out V2. There are reasons for that. The way venturimeter is used, આ બધું એકદમ પ્રેક્ટિકલ છે. વેન્ચ્યુરીમીટર તમે જોયો ન હોય તો અઘરું સ્કૂલમાં વેન્ચ્યુરીમીટર છે. Suppose this is a pipe where you want to measure the flow, so the speed of flow. So venturimeter is adjustable. So what I am saying is this broader section is adjustable. Okay, into this, right? So you put it here, you clamp it. So these two areas will become same. Very good. Now we are interested in finding what the speed here. So we want to find what is V1. We are not interested in finding what the speed here. આનું કઈ કામ નથી. Understood? That's why we are deriving a formula for V1, not for V2. બરાબર? કરવું હોય તો કરે, but it's useless. Okay. So this is the venturimeter formula. Okay. So what are terms? What the like is the term છે જોઈ ને rho m for density of mercury that you are using. G ખબર છે, H for level difference. Rho is density of fluid that is flowing, whose speed you are measuring. V1 is that speed that you are measuring. Capital A, area of the broader section, and smaller area, or can say area of the neck of ventricle. With that. Okay. I think there's a question somewhere. Okay, the question is on page number 261. If you don't like the diagram I have drawn, you can always look at the nice diagram in the book. કેવું સરસ draw કરીને આપ્યું. I hope you found it. Last I put it more thing. Not more book. But you can say Xerox કરેલી કે Okay. This question now. Flow of blood in a large artery of an anesthetized dog, of course. Anesthetized no હોય તો બટકું ભરી જાય આવું બધું કરવા જાવ તો. Understood? The question says the flow of blood in a large artery of an anesthetized dog is diverted through a venturimeter. So we want to measure how much is the speed of flow of blood inside a dog. Okay, so its artery is got, surgery karne ki, right? And there a venturimeter is connected, right? The wider part of the meter in the broader area, that is how much? Looking at capital A, 8 mm square. The narrower part has area 4 mm square. The pressure drop in the artery is 24 pascal, right? Pressure drop. Pressure drop is that. See, they have given it slightly indirect. This is the pressure drop. Right? Decrease in pressure when blood comes from here to there is how much? P1 minus P2, that is 24 pascal. Clear? Right? But this is which is? Find the speed of blood. So suppose you are doing it by this formula. So which value is already given? Rho mg value already given. Put it here. Make sense? Okay, then other values we will have to write it. So root of 2 and this is given divided by rho. Rho for what? Density of the fluid that is flowing. Blood. Blood ની density ગોતો હોય. બુકમાં આપી હશે ક્યાં. નહીતર કાલે સોલ્વ કરજો. ઇન્ટરનેટ ઉપરથી ગોતી. Density શું આવે? Even human blood છે કે whole blood means what you draw. પછી એના બધા પાર્ટ્સ હોય ને તો તમને ખબર હશે ને blood has different parts, right? Whole blood means everything. RBC, WBC બધું પ્લાઝમા ને એવું ખબર ને blood માં હોય, right? Everything together. How much density? So write it here. Okay? And areas are given. One good thing about this question is you don't need to convert the area. Why? Because they are divided. So units will always get cancelled, whatever units you put. So capital A 8 type हो जाएगी. Am I right? And now 4. So division 2 by square करो ना 4 minus 1 है. Are the numbers very complicated? 2 into 24 upon density to the blood is 1.06 into 10 raised to 3. Water they will blood. And this is 4 minus 1. right? 4 minus 1. Still, this is not that simple. 3, 8, 16. 16 by 1.06. 16 by 10.6. 10.6 no root find. 106. 0 to square root 32. They would have. So we are going to do 4. Alright. Divide, what do you get? This is the answer. 0.12 centimeter per second. No answer of that. Answer is given. 0.12 meter per second? આને ડિવાઇડ કરી તો 1.2 આવે. I made a mistake with a zero. આ 1060 થાય ભૂલી જાઓ. 1060 it is 32 ઉપર 38 પછી 4 બરાબર થઈ ગયું. Fine, 0.12 meter per second. Okay. So you see, remembering the formula has advantage, don't you think? You can do it easily, right? Okay, but suppose you cannot remember it, then like I said, don't worry. एक Bernoulli equation લખવાની અને pressure difference is rho g s. It will look not good, but be careful. This is of mercury, and then put whatever values are given and solve. આવી જાય. I clearly remember that when I was studying, I didn't even bother about this. Okay, એના વગર એ સમ થઈ જ જાય બધા. Now go to the exercise and see if there's something which we could do. Okay. Question 14. Now, pehla 16 करना है. It's very small. We might be able to finish. Question 16. Read the question and draw a diagram. Read the question and draw the diagram. Come on. What shape is given there? A cylindrical tube. So draw a tube. Cylinder tube to draw no beautiful. Okay, then how much area? 0.8 centimeter square. Sorry, 8.0 centimeter square. Excuse me. One end of which has 40 fine holes. So on one side there are holes. How many holes? 40. Fine means small. I'm sure you understand that, right? There are 40 small holes on one side. Of how much diameter? 1 mm. That is the diameter of one hole. If liquid flow inside tube is 1.5 meter per minute. Okay. વાંધો નહીં, ખાલી ક્વેશ્ચન ડ્રો કરીને ડાયાગ્રામ ડ્રો કરીને રાખો. નાનું છે solution, but first I'll have to explain what is meaning of liquid flow, right? They have not given the word carefully. Unit જોશો તો કદાચ આઈડિયા આવી જાય. એ એક ખોટું લખ્યું છે. વાહ. They have given speed actually. Unit meter per minute તો speed હોય ને, પણ પાછું લખ્યું છે flow. You don't call flow in meter per second. એટલે કાં તો સ્પીડ લખી નાખવું પડશે. રાઇટ સ્પીડ. ઇફ લિક્વિડ ફ્લો સ્પીડ એવું લખી નાખો. ઇફ લિક્વિડ ફ્લો સ્પીડ ઇનસાઇડ ટ્યુબ ઇઝ 1.5 મીટર પર મિનિટ. હવે બધું સિમ્પલ છે. V1 is given, correct? And what do we have to find? Speed of ejection. How much speed it will come out. So which equation to use? Which equation to use? Continuity. Why? One area is given, the other area is also given. Yes or no? Area of holes hypotenuse indirectly. So you know both areas, you know one speed, and you have to find the second speed. Best choice equation of continuity. Clear? Got that right? I got it. Okay.